Hi there everyone, and welcome again to Cambridge Advanced Level Mathematics, the channel here where we do mathematics. In this video I decided to slow down a little bit and get away from the hard stuff and deal with something a little bit more simple, because we want to deal with the addition and subtraction of matrices. Now, before we get to that, let's talk about matrices themselves. What is a matrix? A matrix is a rectangular array of numbers. For example, A here, I've got the matrices A, B, and C. These are rectangular arrays of numbers. Here we've got 2 rows of them with 3 columns. Again, here we have 2 rows of them and 3 columns. In matrix C, we have 2 rows and 2 columns. Now, the numbers here in each matrix, these are called elements. So this is an element, that's an element, that's an element. A matrix is size. Size of a matrix. Let's talk about the size of a matrix. Maybe I should write at the corner here because I'm going to perform the calculations somewhere here. So a matrix is size. Okay, what is the size of a matrix? It is the number of rows and the number of columns. Matrix A has 2 rows and 3 columns. So it is said to be, so A is said to be a 2 by 3 matrix, meaning it has 2 rows and 3 columns. Matrix B is very similar to A. It is the same size as A because it has 2 rows and 3 columns. So B is also a 2 by 3 matrix. What about matrix C? Matrix C has got 2 rows and 2 columns. So it's a 2 by 2 matrix. It is said to be a square matrix because the number of rows is equal to the number of columns. So the thing to remember is that you give the number of rows first. For A, it's 2. Then you give the number of columns, and it's 3. For B, it's the same thing, 2 rows first, and then the 3 columns. For C, of course, the number of rows is equal to the number of columns, and it's a square matrix. Now, we want to add, for example, let's add A to B. Okay, we want to add matrix A to matrix B. So we will write here our A, 1, 3, 2, and 4, 9, 1 to represent our A, and our B, of course, is 2, 1, 0, 3, 4, 6. Right. How do we add these elements? We add corresponding elements. In other words, elements that occupy the same positions in each matrix. For example, the 1 here is occupying the same position in A as the 2 is occupying in B. So these are 2 corresponding elements. We can pick another element at random in matrix A. Let's pick the 9, circle it in green. The 9 is occupying the same position in A as the 4 is occupying in B. So these are corresponding elements. Lastly, we can choose a third one, which we will circle in blue. The 2 here is occupying the same position as the 0 here. So these are corresponding elements. So we are going to add corresponding elements. And so this is what we do. Here we are. So we say a 1 is added to a 2. So 1 plus 2. That will be the first element of our new matrix, the sum of A and B. Then we come here. Our second element will be a 3 added to a 1. So a 3 plus a 1. Our third element in the first row of our new matrix will be a 2 added to a 0. So it is a 2 plus 0. Now let's come down to the second row. Our first element in the first row will be a 4 added to a 3. So it will be 4 plus 3. the second element in the second row will be a 9 added to a 3. That's the new matrix. So 9 plus 4. Why did I say 3? It's 9 plus 4. Then here, lastly, the last element of the third row will be a 1 added to a 6, which is 1 plus 6. Okay, it's a new matrix. Matrices are, the numbers are put inside brackets. Sometimes in certain textbooks, you might see square brackets. It's all the same thing. Right, let's simplify here. Now we have, I think I can get rid of that because I don't want to write down somewhere here. It might not be very visible. I'm sure we don't need all this. Okay, so we can write now, our answer will be, there it is. Let me put it a little closer. There it is. So 1 plus 2 is 3. 3 plus 1 is 4. 2 plus 0 is 2. 4 plus 3 is 7. 9 plus 4 is 13. 1 plus 6 is 7. This is the sum of matrix A and matrix B. Notice it has the same size as A and B. It is a 2 by 3 matrix. You can't add two matrices of a certain size and add up with the new matrix being a different size. It has to be the same size as A and B itself. In other words, it's 2 by 3, just as A and B were both 2 by 3 matrices. Okay? What about subtraction? Subtraction, not much different. We will perform the same thing, except that this time we are subtracting. So let's not get rid of this nice little picture here, if you like. So now, instead of adding, supposing we want to subtract matrix A minus matrix B. So now, instead of adding, we are subtracting matrix B from matrix A. So A minus B, there is our A, there is our B, and there is our minus sign there. Right. Same as before, we have to deal with corresponding elements. Here is our matrix here. The new matrix will be 1 minus 2. And here it will be 3 minus this 1. And here it will be 2 minus 0. And here it will be 4 minus 3. Here it will be 9 minus 4. Here it will be 1 minus 6. What is the answer? The answer is 1 minus 2 is equal to minus 1. 3 minus 2 is 2. Sorry, 3 minus 1 is 2. 2 minus 0 is 2. 4 minus 3 is 1. 9 minus 4 is 5. 1 minus 6 is minus 5. That is the difference between matrix A and matrix B. Okay, so let's try and go a little further with this. Let's see if we can subtract, let's say, A minus C. Okay, now that we are done with A and B, we can clear this whole part of the board. We want to subtract C from A. So what we want now is matrix A minus matrix C. Again, we do it as before. Here is my matrix A, 1, 3, 2, 4, 9, 1. Minus my C there is 2, 1, 0, 2. Right, we have discovered that we have to subtract or add corresponding elements. Let's see if the elements correspond here. Of course, this one corresponds to that. These two, these 3 here, you might say it corresponds to that 3 here. What about these 2? What are you going to add it to? There's nothing here. You see? So the same applies. You might say this corresponds to that, this corresponds to that. What about this one? What are you going to add it to? In other words, these two matrices cannot be added. In conclusion, we can just say that two matrices can be subtracted from each other or added to each other if they are of the same size. So we noticed last time that our A is a 2 by 3. Our C is a 2 by 2. So these two are not of the same size. They cannot be added or subtracted from each other because they are incompatible. As far as addition is concerned, we will of course discover in our next few videos that with multiplication it is slightly different. Two matrices can be of different sizes and still be multiplied together. But as far as addition and subtraction is concerned, they have to be exactly the same size. So we are going to deal with multiplication in our next video. Till then, bye-bye. Please take care.